Here's question 16.67, and this question deals with citric acid, which is present in citrus fruits, and it's a triprotic acid, meaning it has 3 H plus ions available. The question says calculate the pH of a 0.040 molar solution of citric acid and explain any approximations or assumptions made in the calculations. Additionally, is the concentration of citrate ions equal to, less than, or greater than the concentration of H plus ions?
Alright, so the citric acid will dissolve in a reversible reaction into H plus and H2C6H5O7 negative ions. Now, since this is a reversible reaction, they will achieve a state of equilibrium at some point. Now we're going to use our ice chart to find out exactly how that will work. Initially, the citric acid is at 4.0 times 10 to the negative second molarity. And then it loses an unknown amount, and then the H plus and H2C6H5O7 gain an unknown amount, this being the same unknown amount. We'll call it X. And so then when we reach equilibrium, the value for citric acid will be 4.0 times 10 to the negative second minus X, and the molarities of the H plus and the H2C6H5O7 will both be X. So now we're going to do products over reactants, and that would be X squared, since you're doing X times X, over 4.0 times 10 to the negative second minus X. And we know that will be equal to 8.4 times 10 to the negative fifth, because that is the constant. So we can now assume that X is way, way less than 4.0 times 10 to the negative second. And if we just do the math, we get a number that is sadly more than 5% of 4.0 times 10 to the negative second, meaning that we can't use the way, way less than 4.0 times 10 to the negative second rule, so we'll use a quadratic formula. So then we just put that in quadratic form, and then we have x squared plus 8.4 times 10 to the negative fourth x minus 3.34 times 10 to the negative fifth. And so, using the quadratic formula, we find that x is equal to 5.4 times 10 to the negative fourth. Okay, we've done some math, but we're not there yet. We've still got 2 hydrogen ions to dissolve. So, we take our citric ion that was created last time, and it's going to dissolve further into an H plus ion and a citric negative 2 ion. Now, we're going to use our X result from last time as the initial value of our citric ion, which is 5.4 times 10 to the negative third. And that's going to decrease by an unknown amount, while the H plus and citric negative 2 ion will increase by that same unknown amount. So then we'll put that in the equation and flip it around, and then as a result, what we get is 3.1 times 10 to the negative fourth as our new equilibrium value.
So now to do the last hydrogen ion. Once again, we're going to use the initial concentration for the citric acid, but now we've only got 1 hydrogen ion left. And that concentration is going to be the value of X from the previous step, which is 3.1 times 10 to the negative fourth. The change is obviously going to be minus X, and then plus X, and then plus X. And at equilibrium, we'll have 3.1 times 10 to the negative fourth minus X. And then for the hydrogen ion, we'll have X, and then
the citric negative 3 will also have a value of X. And now our Ka this time will be 4.0 times 10 to the negative sixth. So we plug that in, and we assume that X is way, way less. And as a result, we get X being 3.2 times 10 to the negative fifth. But that does not, does that fit?
Yeah, that fits, but we're not quite done yet because we have to add all of the values of X together.
So now,
one big X.
Now we're going to,
all 3 hydrogen ions.
Yeah, so now we're going to take the 3 X values we found so far, and we're going to just smush them together into one value, which will be 5.7 times 10 to the negative third. So now we find the negative log of 5.7 times 10 to the negative third.
Which is the pH.
Which is the pH, which is
2.24.
And so now,
the last part of the question that we have to answer is the hydrogen ion or the citric ion going to have a greater concentration?
Now, obviously, it's going to be the hydrogen ion.
And why is that, Henry?
Because you've got 3 moles of hydrogen for every 1 mole of citric ion.